All right, so we're going to start introducing some mechanisms. We're going to go over all of these in much greater detail throughout the semester, but we're just going to go ahead and start introducing them now. First off, we're going to start off on radical reactions. And so these are actually relatively rare, but let's go ahead and go over it anyways. And so a radical reaction involves a radical, which is an unpaired electron. Right, so maybe you have a carbon with just one electron, right? Maybe three other bonds, something like that. But you have one unpaired electron. That's a radical. And radicals are highly reactive. They're not very stable. And so we can draw mechanisms for reactions involving radicals. We draw the arrows differently for radicals than we do for lone pairs. So for radicals, when we're showing the flow of one electron, we use a half hook arrow. Whereas when we show a lone pair, we use a full hook arrow or a double hook arrow. And so, right, there's two, if we have an A-B bond, right, and let's make it a CC bond. There's two ways we can break it. One is to have one electron go on either side, in which case we would form two radicals. This is called homolytic cleavage. Or we can have both electrons go on the one atom, in which case we'll form some charge. This is called heterolytic cleavage. Most of organic chemistry is going to be the second one, but for now we're going to focus on this first one. And so there's three main steps to any radical reaction. And the example here will be going from methane plus chlorine in the presence of UV light will form chloromethane and hydrochloric acid, HCl. So the first step is initiation. And this is when the reaction begins. In initiation, usually UV light, not always, sometimes heat or some other compound, but UV light generally forms the initial radicals. In this case, it's going to be our chlorine bond breaking homolytically. So we're going to have one electron go on this chlorine, the other electron go on this chlorine. Right, and then we're left with two neutral radicals. The second step is called propagation. And in this case, a radical reacts with a non-radical. To form another radical. And so on and so forth, right? So this step can go on repeatedly and repeatedly. So for example, maybe one of our chlorine radicals meets one of these methanes and it can react homolytically or homolytically, right? So we'll have this lone electron go here. One electron from these bonds is going to form a CLH bond, and then the other electron in this bond is going to go on the carbon. So what you want to be able to do is follow where these electrons are going. So we're forming a CLH bond, and then we're left with a radical on the carbon. And this radical with this carbon can go on and interact with other compounds. So maybe it finds a chlorine atom and propagates further, right? So you see this step, we start off with a radical and then we end with a radical. And then finally, this third step is termination. And so in termination, two radicals react and terminate one another. Overall, it's going to be a pretty rare step because the concentration of radicals is going to be pretty low, so the chances that they encounter each other is pretty rare. So you could have maybe, for example, a chlorine and a chlorine combining to form a Cl-Cl bond, maybe a chlorine radical and this methyl radical. Notice the use of these half hook arrows. Or maybe two methyl radicals meet each other. And so while radical reactions are relatively rare, they'll form the basis of forming our haloalkanes, which we'll use to synthesize other compounds. And we'll spend more time on radical reactions later. This is just showing you the overall steps, and you want to understand and know these steps.